These rocks have been cut out of the earth, sometimes 50, 60 years ago, some more recent, but they're from locations that will never be accessed again.
This is a library of the Earth's deposits. We are the largest archive of geologic materials in the United States.
The facility we have here in Austin is one of three that the Bureau has in Midland, Texas, and also in Houston, Texas. And there are cores not just from the state of Texas, but there are cores from all of North America and some from even other countries around the world.
We want to provide a good service for the public and for industry and for our research staff.
The Bureau has been involved in this in a little bit more than 100 years. There's a fellow by the name of Johannes Udden that came to the Bureau in the early teens. We started samples first, that was the thing. Then later, because that was what was available. And then coring became common in about the 1920s. And so we started the collection of cores.
This is a 93,000 square foot floor plan. It was built around 1984. And it was for strictly the purpose of geologic core storage.
And when I started here in 1986, the repository was probably at about 30% capacity at that point.
The Bureau embarked on a program of acquiring cores from many companies that actually cut cores, mostly oil and gas companies. And now we have one of the largest collections in the world. And it's fundamental to the research we now do here.
Within about 4 years, we hit 80% capacity. It was amazing how fast. It's like a vacuum. Once people, it just filled up as soon as it opened up.
There aren't many universities that could manage facilities like this. And University of Texas at Austin is one such university. We have major facilities in many different disciplines. And this is one of the biggest and best of its kind in the world for geologic preservation of data. Our core viewing room is in high demand. We have a month waiting list just to look at rocks. And it's not just because oil and gas people come look at these cores, they do. But students that are studying the rocks with their professors, folks who are working in the hydrogeology world, mineral exploration, looking at geothermal systems, and the list goes on and on of the different kinds of users, all needing to look at these fundamental rock systems.
In that multidisciplinary approach that the Bureau and more broadly the Jackson School of Geosciences has, really brings to bear a kind of expertise that's probably not to be equaled anywhere else in the world.
It's an interesting and a wide variety of people that I meet. That's kind of what makes the job fun. So I might be talking to a truck driver one minute, turn around and be talking to the president of an oil company in Finland the next, so I never know.
And we're really looking at different ways to analyze rocks quantitatively, right? And so why does anybody else actually care? Is we can use this to help find oil or gas or things that we need today in society to make plastic products, chemicals, oil for your car, petroleum. And using these elemental data sets, we can find where those areas are to help industrial utilization.
We've got a great crew of people. This is not an easy job, but it is fun and we like our work. And we take it very serious because we appreciate the value of what it is that we're working with.
The value is incalculable. If you wanted to replace it, okay. The well, maybe where this core was cut, it may have cost $5 million to drill. Is the core worth $5 million? It is. If you wanted the core, you'd have to go out and spend another $5 million to get it.
These are rocks that tell the story about the subsurface. Whenever possible, we get out into the field and look at outcroppings of rocks. The reason why we look at the cores is in so many places that's not possible.
In-depth studies of these rocks draw analogies to the outcrop and then to the subsurface.
The geologic record there is enough to help increase our knowledge of both how the Earth got to where it is today and possibly where it's going to go tomorrow.
We are basically historians. We're really fascinated with trying to turn the pages of Earth history. And every time you uncover something new, or when you make observations that you can interpret and you can make one observation compared to another, build the story, it's fun.
There's no substitute for being able to see the actual rock record. That's vital. And so by keeping and curating and storing this remarkable facility, we're able to look into the future and know that no matter what comes down the road, we still have that raw information here for future scientists and investigators to use. The question I ask is, what's the next reservoir in the future? What's it gonna be? And my guess is we have it somewhere out here.
This is a special kind of a bit that we call a core bit, and it's used to rotate and cut away a section of the rock through which we're drilling. The section might look like this. This happens to be a core sample of a shale. This is brought to the surface and again used by the geologist to determine the kind of formation in which we're drilling.